Talking about neutralization reactions. And we've talked about them before. Like when we talked about types of equations, we talked about neutralization reactions. But since we've looked a little bit closer at acids and bases, I want to talk about what it means, right? So we know from last week that if we're looking at the pH scale, the dead center in the middle is the number 7. Anything with a pH of 7 is neutral. Now, acids are going to have a pH less than that. So anything that has a pH less than 7 is going to be an acid. Anything that has a pH greater than 7, up to 14, is going to be a base. Did that not come out? Oh, that's not wanting to write there. Okay, well, it should say base. I don't know what that says, but it should say base. So acids can be really dangerous. They can react with skin. They can react with all kinds of stuff, metals. Bases, same thing. They react in a different way, but they're also really highly reactive and dangerous. And so what we're going to do is we're going to put together an acid and a base. And the acid over here and the base over here, they're going to come together and they're going to create a neutral substance. So we are neutralizing our dangerous acid and our dangerous base by putting them together and creating a neutral solution. And what is in that neutral solution? Well, it's two things. It's going to be water and an ionic compound, which we call salt. Now, it's not always NaCl. I know when you guys hear salt, you think of table salt, right? NaCl. In chemistry, a salt is any ionic compound. So basically what you're going to end up with is water in some ionic compound. Okay? How does this work? Well, last week we talked about acids. And Arrhenius and Bronsted-Lowry defined them differently. Arrhenius talked about H+, right? Hydrogen ions. And Bronsted and Lowry talked about a proton, but a proton is an H+, so it's literally the same thing. And that's what acids have, okay? Bases tend to either pull hydrogens off of water or produce hydroxide. So bases are associated with the hydroxide ion. And when you put hydrogen together with hydroxide, they're going to make H2O, 2 hydrogens and an oxygen. It's going to make water. So my dangerous substance and my dangerous substance, they come together and they make water. Now there's other stuff in there, and so that other stuff makes up that salt, okay? Now we have to do this just right. You can't, you want to make sure that all your acid and all your base have reacted, right? You don't want to have more of one or the other because then it's not safe, right? We haven't neutralized them. So we have to reach something called the equivalence point. Which means that we have an equal number of moles of acid and base. So at the equivalence point, I have exactly the same amount of hydrogen and hydroxide. And so what really happens is that those reactants are used up. They're converted to products. And so instead of acid and base, all we have now are our products, salt and water. Now, years ago at the old high school, there used to be a chemistry teacher, and they would do a demonstration, which is a really dumb demonstration. They would take an equal amount of acid and base and put them together. The acid was strong, the base was strong, both substances were dangerous, but when you put them together and they're exactly equal to each other, you just have salt water. So then the guy would drink it to prove that it wasn't dangerous anymore. Now, that's a super bad idea because if you're off even just a little bit, like you're drinking acid and base, like that's really dumb. And then also, I don't know if y'all have seen my glassware, but I never clean it. So he's just drinking some crusty stuff from God knows when. Just a really bad idea all around. So I'm not doing that demonstration because I like my life. So I'm just telling you about it. But that's the equivalence point. At the equivalence point, acid and base are gone, and you just have salt water, which isn't dangerous, okay? So we need to figure out like how to get equal amounts of acid and base. We need to figure out how to calculate the amount of stuff required to reach that equivalence point. And so I pulled a example problem that's a lot like the problems on your homework assignment. And we're going to talk about the steps in solving it, okay? So problem was what volume of 0.10 molar hydrochloric acid is required to neutralize 50 milliliters of 0.12 molar magnesium hydroxide. So I know right here it says step 1, calculate something called the normality. Okay, but you know what? Step 0 is look at the compounds that are in our problem and figure out which one is the acid and which one is the base. That's an important skill. Like, you guys need to be able to look at a formula and tell me if it's an acid or a base. So let's look at this one right here, HCl. Would that be an acid or a base? Close. Yeah. So the trick is, here's my trick to figuring this out. We got 2 compounds, right? The one that starts with H is the acid. The one that ends with H is the base. Specifically, it ends in hydroxide, OH. That's definitely going to be a base, right? Because the Arrhenius definition of bases said they had to have hydroxide. For Bronsted-Lowry bases, you're probably just going to see H, not OH at the end of it. So, but it's still a good trick. Whatever starts with H is your acid. Whatever ends with H is probably your base, okay? And then we're going to need to figure out this part right here. Before we do any other math, what I want to do is look at those chemical formulas and figure out how many H's and how many OH's are present in those chemical formulas. Now this one's easy. It's just a single HCl, correct? So there's 1 hydrogen in that chemical formula. You just have 1 hydrogen up front that's going to dissociate in water. If we look at the base, do y'all see that there's parentheses around hydroxide with a 2? That means that every time this compound dissociates in water, I'm going to get 1 magnesium, but I'm going to end up with 2 hydroxides. So I actually get double the hydroxide off this compound. So when we do our math, when we look at the number of hydroxides, for that one it's going to be 2. So I looked at the formulas, I identified my acid and my base and figured out how many hydrogens and hydroxides they have respectively. Now I can use that to figure out something called normality. And this is a real easy thing to calculate. It's kind of like moles when we were doing, you know, the molarity triangle and stuff, molarity calculations. We're using molarity and we're using volume. We're also using the number of ions that dissociates. And we're going to figure out like how much H plus and how much OH minus there is. So we just multiply molarity. So for the acid, let me look. Said right here we had 0.10 molar HCl. So my molarity of acid is 0.10. We're going to multiply that times the volume. Now that's the issue, right? Question is, what is the volume? So since I don't know the volume, I'm just going to put X in there for that one. And then we have to multiply that by the number of hydrogens in the chemical formula that will dissociate. And for hydrochloric acid, that's just a single hydrogen. So if I take my molarity, 0.10, multiply it by my unknown, multiply it by 1, that gives me 0.10x. You guys okay with that one? All right. Same idea for the base. Let's figure out how much hydroxide we've got. Molarity of the base, they gave us that. It's 0.12. Okay. They also gave us the volume. They said we had 50 milliliters of this magnesium hydroxide. So I'm going to put 50.0 there. And then we figured this out by looking at the chemical formula. Every time this guy falls apart, we're going to get 2 hydroxides. So I'm going to multiply it by 2. $50 times 2 is 100. 100 times 12 hundredths is going to be 12. So this is the normality of my acid. This is the normality of my base. Okay? Easy stuff. Now the important idea that we talked about is that we're trying to get to the equivalence point. And one more time, at the equivalence point, my moles of acid, which is my H plus, right, has to be equal to my moles of base, which which is that OH minus hydroxide. So what we're going to do is set the normality of our acid equal to the normality of our base. We just calculated those. The normality of our acid was 0.10x. The normality of our base, 12. So I set those two values equal to each other. We have 0.10x equals 12. So now this is just real basic algebra. We just have to solve for x here. And I'm going to do that by dividing both sides by 0.10. And dividing by a tenth is the same thing as multiplying by 10. So this comes out to be 120. So my answer is 120. The unit for that answer, because my first volume was given in milliliters. This is still scrolling on its own. This is doing all kinds of things. So right there, my first volume that I put into the problem was in milliliters, so my new volume is also going to be in milliliters. And this was the volume of HCl, so this is going to be milliliters of HCl. Did not want to go that far. Okay. So there it is. It would take 120 milliliters of that hydrochloric acid solution to neutralize the 50 milliliters of magnesium hydroxide we had. So if I wanted to reach the equivalence point, that's how much acid I would have to add to the base to end up with salt water. There's a shortcut for this. I mean, basically, we had a formula for acid, we had a formula for base, and we set them equal to each other, yes? So the shortcut is just to go ahead and fill in all the blanks, right? Take the molarity of the acid, multiply it times the volume of the acid, multiply it times the number of hydrogens in the chemical formula that dissociate. Set that equal to the base information. Molarity of the base times the volume of the base times the number of hydroxides that dissociate from the chemical formula, or the number of protons it accepts. It just depends on whether it's an Arrhenius or a Bronsted-Lowry base. So listen, we could have set up the problem like this and done it real quick and easy. Molarity of that acid was 0.10. We didn't know the volume. 1 hydrogen in hydrochloric acid. Set that equal to molarity of the base, 0.12 times 50. There were 2 hydroxides in the chemical formula for magnesium hydroxide. Then it's just algebra again, right? I'm multiplying, so this becomes 0.10x. I'm multiplying on this side, so that becomes 12. And after I've multiplied each side, then I divide to solve for x. So remember order of operations, make sure you multiply before you divide. And again, we were trying to find the volume of hydrochloric acid required to neutralize the base. And since the volume of base was in milliliters, the volume of acid is also in milliliters. Do you have any questions about how I set that one up? You guys are going to be able to use that shortcut formula a lot. And I want you guys to know that while you're calculating the equivalence point, when you're trying to figure out the molarity or you're trying to figure out the volume required to get to that equivalence point, it is going to be exactly the same for weak acids and bases, right? We're going to use the same formula. It's going to be exactly the same as when we're calculating the equivalence point for strong acids and bases. So it doesn't matter whether you've got a strong or weak acid. If you're trying to calculate the equivalence point, you're trying to figure out how much to add to reach that equivalence point, you're going to be using that same shortcut formula up here. Okay? Doesn't matter what the identity of the acid or base is. right, good stuff. Take a look at the homework then. Most of the problems on this assignment, you're going to be using that shortcut formula. They're asking you to figure out how much it takes to neutralize. So if they're asking you how much does it take to neutralize something, they're asking you to figure out that equivalence point, because that's where it's neutral. Okay? Okay, so if they're asking you to figure out how much it takes to neutralize something, they're asking you to do the equivalence point calculation. And again, that shortcut, you're going to take the molarity of the acid, multiply it by the volume of the acid, times the number of hydrogens that dissociate from the acid. You're going to multiply that by the molarity of the base, times the volume of the base, times the number of hydroxides that dissociate, or the number of protons it accepts. It just depends on what kind of base it is. So for most of these problems, that's going to be the formula you use. I'll do the first one with you to show you guys how it works. Question is, what volume of 0.100 molar sodium hydroxide in milliliters is required to completely neutralize 50 milliliters of 0.25 molar HCl? So remember, step 0, before we even get into the numbers, let's just figure out what's what. Here are my two substances. Which one is the acid and which one is the base? Yep, ends in hydrogen, ends in hydroxide specifically, so that's the base. That one starts with H. There's my acid. Easy to identify, right? Okay. So the question was what volume of sodium hydroxide? So it looks like we've got to figure out the volume of base. That's going to be our unknown this time. They gave us a molarity. So this right here is the molarity of that base. So I'm going to plug that in the formula where it says molarity of base. Do you see how identifying the acid and the base kind of helps me figure out where I'm plugging numbers in? Down here, they gave us a volume of HCl. So this is the volume of the acid, and this right here is the molarity of the acid. The only other thing we need to figure out is how many hydrogens and how many hydroxides, right? Well, if I look at NaOH, isn't there just a single hydroxide on there? There's no parentheses, there's no subscript, so this is just going to be one OH. So where it says the number of OHs, we're going to plug in the number 1. And then we already talked about HCl. There's only one hydrogen there. So when we do our math, we're going to plug in 1 for the number of hydrogens. So now it's just a real simple algebra calculation. We just need to substitute these values into the equation where they belong. First up is the molarity of the acid, 0.250. We multiply that times the volume of the acid, 50.0 milliliters. And then there's just one hydrogen that dissociates from hydrochloric acid. On the other side, we have a molarity of 0.100. And the volume of the bases are unknown. So that's where we're going to put an X in. That's what we're trying to figure out. And when we looked at the chemical formula for sodium hydroxide, there's just a single hydroxide ion on there. So we dropped the number 1 in there for the number of hydroxides. All right, so remember your order of operations. Multiply first. 0.25 times 50 is going to be 12.5. So that side of the equation, once we multiply everything, 12.5. 0.100 times x times 1 turns out to be 0.100x. Any questions about the multiplication part there? All right. And then to solve for x, we need to divide both sides by 0.100. So 12.5 divided by 1/10 is going to give us the volume of sodium hydroxide we need. And I think that's 125. Is that correct? Since the volume of acid was milliliters, then this volume we've calculated is also in units of milliliters. There were 3 significant figures in each given value in the problem. So we can keep all 3 of these significant figures right here, and we're good. It would take 125 milliliters of sodium hydroxide to neutralize 50 milliliters of this 0.25 molar hydrochloric acid. Is it the sig fig thing?
I got 0.008, but I think that's
Oh,
I'm divided by
yeah.
12.5.
That happens a lot. So make sure that when you do this, it's always the number side divided by the x side. Yeah, and then you'll get the right one. So yeah, it's going to take 125 milliliters of sodium hydroxide to neutralize all that acid in there. Okay, so listen, most of the problems on this worksheet just like that. You're going to plug the numbers into that equation, solve for the unknown. There are a couple of problems down here that are different. So go to number 10. In some of the problems, they have not asked you about neutralizing anything or finding the equivalence point. In question number 10, they're asking you to calculate the pH of a solution that results from acid and base being added together. Now, if it is the equivalence point, if we do have exactly the same amount of acid and base, what should the pH be? What's a neutral pH? Yeah, 7. So if you end up with exactly the same amount of acid and base, pH is 7 and you're done. We've got to figure out whether they're equal though, and so what we're going to do is we're going to do things a little bit differently. So the first step in one of these problems where, you know, I've got an amount of acid, I've got an amount of base, and I need to figure out whether or not it's neutral, we're going to calculate the normality. We're going to go back to separating them. We're going to calculate the normality of the acid first. Then we're going to calculate the normality of the base. And it doesn't really matter if you do the base first or the acid first, just we're going to calculate the normality of each separately. So we're not setting them equal to each other this time because we don't know whether or not they're equal to each other. All right, the first one that they gave me numbers for is this CaOH2. Acid or base? Base. And if we look at this chemical formula, 2 hydroxides, correct? So when we plug in the number of hydroxides, it's going to be 2. So for the normality of that base, I'm going to take the molarity they gave me, 0.100, multiply it times the volume they gave me, which was 30, and then multiply that times the 2 hydroxides in that chemical formula. So 30 times 2 is 60. Multiply that by a 1/10, and it's just 6. So that's how much hydroxide we've got in there, okay? Let's do the same thing for this acid right here. This other chemical is our acid. Do y'all see how it's H2SO4? So this one actually has 2 hydrogens, okay? We've got 50 milliliters of it, and its molarity is 0.150. So 0.150 is my molarity. Multiply it times the volume, which is 50. Keep in mind that 2 hydrogens are produced every time that stuff dissociates. So the normality of this acid, 50 times 2 is 100 again, right? 100 times 0.15 is going to be 15. Okay, so look at our numbers. Do we have an equal amount of each? No. We've got a lot more H plus in this solution than we do hydroxide. And if I have more acid, if I have more hydrogen, then this is going to be an acidic solution. And before I do anything else, I can already tell that my pH is going to be less than 7. This is not neutral. I have a lot more acid, so my solution should have an acidic pH. So here's the next step. Let's figure out how much acid is going to end up floating around. These two are going to react with each other until one of them disappears. It's like a limiting reagent problem. So the hydroxide is going to run out first. Let's find the difference. 15H plus. I subtract the 6 hydroxide that's going to react with it. What I have is 9 hydrogen in excess. This thing is not wanting to write very well. I have an extra 9 acid parts floating around in my solution. Okay, the hydroxide reacted until there wasn't any more hydroxide, but I still have 9 hydrogen in excess. So in order to get pH, we have to figure out the molarity of that hydrogen that's floating around in there. And we have the little triangle to help us with molarity calculations. Y'all remember that? Remember this guy right here? Now what we have here, it's not exactly moles because we use milliliters to figure it out. It's actually millimoles, but that's okay. I can take the 9 that we calculated we had in excess, and I can divide it by the milliliters, the volume of the solution, to get my molarity of hydrogen. So if I know that I have 9 hydrogens floating around in, let me think about the volume real quick. We had 30, we added 50. So if you had 30 milliliters in your beaker and you added 50 more, what is your beaker going to say now? 80, yeah. So we've got 9 hydrogens floating around in 80 milliliters of water. If I take the number of particles and divide it by the volume, that's going to give me my molarity. What do you get for that one? Y'all are going to have to punch that in the calculator for me. That one I can't do in my head. I can't mental math that one. Okay, awesome. So what we just did was we figured out the concentration, aka the molarity of hydrogen. And that's what we need to do our final part. We need to figure out the pH. So last week we talked about pH, and we said that pH is calculated using just some quick and easy buttons on the calculator. It's the negative log of your hydrogen ion concentration. Log is just a button on the calculator. So you're literally going to punch in the negative button, then you're going to hit the log button, which is on the left side of your calculator, and then you're going to put in this number right here for our hydrogen molarity, 0.1125. What'd y'all get?
It's supposed to be 3 or 4, right?
Yeah, you can leave 3 decimal places in your answer.
Okay, so it'd be 0.949.
949. Now that value is less than 7, correct? So that makes sense. We predicted that this was going to be an acidic substance because there's still a lot of excess hydrogen floating around, and that our pH, because it's acidic, had to be less than 7. So that pH value that's real low, that makes sense. Okay? Now you only have to do that for the ones that say calculate the pH. So all the ones that say calculate the pH, those are going to be the ones where you have to go through this process right here. The other ones that are asking about equivalence point, aka neutralization, those are the ones where you get to use your shortcut formula, your Ma, Va, number of hydrogens, equal to molarity of the base times the volume of the base times the number of hydroxides in the base, and you just do your quick and easy algebra. Okay, so any of the ones that mention neutralization or equivalence point, you're using that shortcut formula. The other ones that say, I've got this much acid and I've got this much base, if I put them together, what's my pH? That's where you're going to have to go through that longer process of figuring out how much acid and base you really have, figuring out which one's left over, which one's in excess, and then basing your calculation off that. Okay.